So on Friday, your assignment was about the fundamental counting principle and how we can figure out the total number of outcomes from, or in a compound event, from the outcomes of both of the simple events. So let's review that. And what it says is I can take the outcomes of one of the events, the outcomes of the other event, and multiply them and get the total number of outcomes. So for example, William will toss a coin and roll a number cube with sides labeled 1 to 6. How many outcomes are possible? Well, I know that a coin, okay, there's my wonderful circle, has two outcomes. I can have heads or tails. And I know that the cube if it's labeled 1 through 6, has 6 outcomes. So if I want to quickly figure out the number of outcomes, I'm going to take 2 times 6 and get 12 for my number of outcomes, because I want to know the outcomes for tossing a coin and rolling a cube. And remember, and means we are going to multiply. Okay, so toss a coin and roll a cube. We are going to multiply the outcomes by one another. Any questions about that? Good morning, Anneli. Good morning, Mariana. Okay, let's look at another one. Doubles are rolled when 2 number cubes land on the same number. If Jane rolls 2 number cubes labeled 1 to 6, how many outcomes would not result in doubles? So the first thing I want to know is the number of possible outcomes. Okay, that's what we need to figure out first. So how many possible outcomes do I have from rolling 1 cube? How many possible outcomes from 1 cube? 6. Okay. How many outcomes on the second cube? Right, there's still 6 because they're both labeled 1 to 6. So if I want to know the number of possible outcomes, am I going to add 6 plus 6 or multiply 6 times 6? Right, we're going to multiply. So 6 times 6 gives me how many possible outcomes? 36. All right. Our question, though, wants to know how many would not result in doubles. So if I roll 2 number cubes, and let's say I roll a 1 the first time, or on the first cube, the second cube would also have to be a what for it to be a double? Right, because it has to be the same number. Okay, what other doubles could I roll besides 1 and 1? I could roll 2, 2. 3, 4. Sorry, my computer's acting crazy. 5, 5, and the last one, I already see you already answered 6, 6. Okay. So out of the 36 outcomes, how many of them are doubles? Right, these are 6. So if I have 36 outcomes and 6 of them are doubles, how would I figure out how many are not doubles? Not divide. It's another way to reduce. We're going to subtract. So we're going to take our total outcomes minus the ones that are doubles and get the number that is not doubles. So 36 minus 6 gives me 30. So of these 36 outcomes, 30 of them are not doubles. Any questions about how I did that one? All right. Any questions about how to find the possible outcomes by multiplying with the fundamental counting principle? Okay. All right, let's do a quick review of with replacement and without replacement. Okay, let me make sure I have the right ones. So in a bag, there are 5 cards, 1 to 5. So I have 1, 2, 3, 4, 5 on my cards. Each time a card is randomly selected, it is replaced in the bag. So it is replaced, meaning this is with replacement. What is the probability Marcia will select an even numbered card first and then a odd numbered card? So we want to know the probability of even, then odd, okay? So I first need to figure out what is the probability of an even number and the probability of an odd number. So 1, 2, 3, 4, 5, what is the probability that I'm going to draw out an even number? Two-fifths. Remember, probability is a fraction. A lot of you are forgetting that. Yes, there are 2 even numbers, but probability is the number out of the whole. So 2 out of 5, okay? All right, if even is 2/5, what is the probability of odd? Right, 3/5. How would I figure out the probability of pulling even and then odd? What am I going to do with these 2 numbers? Even and then odd. So if it's and we, nope, if it's and we, we're either going to add or multiply. Yariel says multiply, and that would be correct. So we're going to take 2/5 times 3/5. And remember, when we multiply fractions, we do numerator times numerator, so 2 times 3. Is 6. And 5 times 5 is 25. So the probability of pulling an even card and then an odd card is 6/25. Any questions about that one? Okay. Let's look at the next one. Thomas has 4 red, 2 green, and 2 yellow marbles in a bag. Without looking, he reaches in the bag, pulls out a green marble, and puts it on the table. So when we read this sentence, he reaches in the bag, pulls out a marble, and puts it on the table. Is he putting it back in the bag, or is he setting it to the side? Are we replacing or not replacing? We're not replacing, okay? So that means my number of outcomes the second time is going to go down by 1. He reaches into the bag. What is the probability he will pull out a yellow marble? Okay. So let's figure out how many marbles are in the bag to start. 4 red, 2 green, and 2 yellow. So if I add 4 plus 2 plus 2, how many marbles does he start with? Right, 8. Now he is going to pull out, I'm going to label these. Oh, that is not green. That is supposed to be yellow. So he pulls out a green marble, which means that I now have 2 minus 1 green marbles. So I still have the 4 red. 2 minus 1 green marbles would be 1 green. And I still have 2 yellow. So after he pulls out that 1, how many marbles are left in the bag? All right, there are 7. And the question wants to know, what is the probability with that pick that he will pull out a yellow marble? So what is the probability that he will pull out a yellow marble out of those 7? 2/7, because there are 2 yellow marbles still in the bag. Any questions about that one? Okay. All right, any questions about finding the number of outcomes or with and without replacement? All right, let's talk about your assignments and then we'll talk about the rest of the week. So your assignment for today, and if you've already been in Canvas, you've probably noticed that you don't have a warm-up this week or today. I did not do any warm-ups this week, no exit tickets, because I know some of us have missing work to complete. So your main assignment is called to replace or not to replace. That is the question. So it's all about replacement and without replacement. And it's all going to center around this second slide. So make sure you read this very carefully. It's going to use the jar of candies that you see here, and a game that Joshua and his sister are playing. So read slide 2, read slide 3, and you're going to try to figure out which situation is better for Lisa and better for Joshua. Okay. So we're going to start with Joshua's plan. What is the probability she will pick out a lemon sour ball? So red are cherry, yellow are lemon. What is the probability she'll pick out a cherry? Probability of lemon first and cherry second. So this one is with replacement. So she's going to pick one out, put it back in. So our number of outcomes is going to stay the same. And then answer question 4. Then we're going to do Lisa's plan, which is without replacement. So she's going to pick a lemon out, or say she picks a lemon out, probability. How many are in the jar after she takes one out? And then out of what's remaining, the probability of cherry. So if there are 6 in here, she takes one out. You're not going to say that the probability of cherry is out of 6 because there's not 6 in there anymore. Figure it out. Remember, this is and, so this times this. And then answer the question. Which situation does Lisa have a better chance of getting 2 different ones? And if Joshua wants to keep all his candy, which one should he choose? Explain both. And then on slide 7, you're going to read the little paragraph up here, and you're going to figure out which of the 4 challenges gives Lisa the better chance of keeping the sour ball, okay? And explain why. So you can explain with words, you can explain with working the problem out or the problems out and showing your work. But I need to see somehow that you understand which one is better for Lisa, okay? And yes, I worked all these out too, so don't just pick one. I want you to actually try and see if you can figure it out. Any questions about your main assignment? And then you have IXL to do after that. All right. Let